The moon, our celestial companion, has captivated humanity for millennia. This celestial dance partner is tidally locked to Earth. This means we only ever see one face of the moon, the near side. This familiar face with its dark Maria and bright highlands has been the subject of countless myths, legends and scientific inquiries. However, there exists another side to the moon, a hidden hemisphere that has long remained shrouded in mystery, the far side. For centuries, the far side of the moon was a realm of speculation and imagination. Hidden from our view, it fueled countless stories and folklore. Some imagined it to be a world teeming with alien life, while others believed it to be a desolate wasteland. However, the dawn of the space age heralded a new era of lunar exploration. The early glimpses of the far side provided by Luna 3 ignited a thirst for more detailed exploration. However, reaching this hidden hemisphere posed significant technical challenges. Unlike the near side, which enjoys constant communication with Earth, the far side is perpetually facing away from us. This lack of direct line of sight made communication with spacecraft on the far side impossible without a dedicated relay system. Despite these challenges, the allure of the unknown proved too strong to resist. Subsequent missions, both from the Soviet Union and the United States, sought to further unveil the secrets of the far side. These missions, though limited in scope, gradually refined our understanding of this enigmatic region. The Apollo missions, while primarily focused on the near side, also contributed significantly to our knowledge of the far side. Astronauts in lunar orbit were able to capture high-resolution photographs of the far side, providing invaluable data for scientists back on Earth. These images revealed a world scarred by countless impact craters, a testament to the moon's long history as a celestial shield for Earth. However, it was not until the early 21st century that a new generation of lunar explorers would truly begin to unravel the mysteries of the far side. Advances in spacecraft technology and communication systems paved the way for more ambitious missions, culminating in a historic landing that would forever change our understanding of the moon. In January 2019, China's Chang'e 4 mission achieved a historic milestone, the first ever soft landing on the far side of the moon. This remarkable feat of engineering and technological prowess marked a new era in lunar exploration. It opened a window into a region that had remained largely unexplored for billions of years. The Chang'e 4 mission consisted of two main components, a stationary lander and a rover named U-22. The chosen landing site was the von Karman crater, a vast impact basin located within the even larger South Pole Aitken Basin. This region is of particular scientific interest as it is believed to hold remnants of the moon's ancient mantle, material excavated from deep within the lunar interior during the impact that formed the basin. To overcome the communication challenges posed by the far side's lack of direct line of sight to Earth, China launched the Queqiao relay satellite into a halo orbit around the second Lagrangian point, L2, of the Earth-Moon system. This strategic positioning allowed Queqiao to maintain constant communication with both the Chang'e 4 lander and ground stations on Earth, acting as a vital communication bridge. The successful landing of Chang'e 4 and the deployment of the U-22 rover marked a pivotal moment in lunar exploration. It demonstrated China's growing capabilities in space exploration and set the stage for a new wave of scientific discoveries from this previously unexplored region of the moon. Unlocking geological secrets, the composition and history of the far side. The Chang'e 4 mission, with its suite of scientific instruments, studied the geology and composition of the von Karman crater. The U-22 rover explored the lunar surface, collecting invaluable data with its ground-penetrating radar and spectrometer. A key objective was to study the composition of the lunar regolith, the loose material covering the moon's surface. Analyzing spectral signatures provided insights into the geological processes shaping the far side. Data supported the theory that the South Pole Aitken Basin was formed by a massive impact. This impact excavated material from the moon's mantle, exposing it on the surface. The rover detected minerals like olivine and pyroxene, characteristic of the lunar mantle. Ground-penetrating radar revealed the subsurface structure of the far side in detail. Radar wave reflections helped map the layers beneath the surface, revealing the region's geological history. These findings shed light on the impact cratering and volcanism shaping the moon over billions of years. A silent sanctuary. The potential for radio astronomy. The far side of the moon offers a unique advantage for radio astronomy. It is perpetually shielded from Earth's radio noise. This makes it an ideal location for sensitive radio telescopes to detect faint signals from the early universe. Earth's atmosphere blocks many wavelengths, including much of the radio spectrum. This makes it difficult to observe the universe at these wavelengths from Earth's surface. Additionally, human activity creates constant background noise. The far side of the moon is a haven of radio silence. The moon's bulk blocks all radio signals from Earth, creating a pristine environment for radio astronomy. A radio telescope on the far side of the moon could observe the universe at wavelengths impossible to observe from Earth. One exciting prospect is observing the universe at very low frequencies, below 30 MHz. These frequencies are blocked by Earth's ionosphere. Observations at these frequencies could provide valuable insights into the early universe. Future ambitions, upcoming missions, and their objectives. The success of the Chang'e 4 mission has spurred a renewed interest in lunar exploration, particularly of the far side. Several space agencies and private companies are currently planning or developing missions to further explore this enigmatic region. China has outlined ambitious plans for its future lunar exploration program, which includes the Chang'e 6 and Chang'e 7 missions. Chang'e 6 is slated to be a sample return mission, aiming to collect lunar regolith from the far side and return it to Earth for analysis. This mission would provide scientists with invaluable samples for laboratory study, allowing for more detailed analysis of the moon's composition and history. NASA, in collaboration with international and commercial partners, is also actively pursuing lunar exploration through its Artemis program. While the primary focus of Artemis is to establish a sustainable human presence on the moon, with a particular emphasis on the lunar South Pole, the program also includes plans for robotic exploration of the far side. Private companies are also playing an increasingly prominent role in lunar exploration. Companies such as Astrobotic and Intuitive Machines are developing lunar landers and rovers, offering their services to both government agencies and private customers. These commercial endeavors are making lunar exploration more accessible and affordable, paving the way for a new era of lunar science and discovery. Conclusion: expanding our horizons. The far side of the moon, once a hidden hemisphere shrouded in mystery, is gradually revealing its secrets. From the first grainy images captured by Lunar 3 to the groundbreaking landing of Chang'e 4, our understanding of this enigmatic region has advanced significantly. Exploring the far side of the moon is not merely about satisfying our curiosity about our celestial neighbor. It is about pushing the boundaries of human knowledge and understanding. It is about unraveling the mysteries of our solar system's formation and evolution. It is about searching for answers to fundamental questions about our place in the cosmos. The discoveries made on the far side of the moon have profound implications for our understanding of the moon's history, the early solar system, and the potential for life beyond Earth. The unique environment of the far side, particularly its radio silence, offers unprecedented opportunities for scientific exploration, particularly in the field of radio astronomy. As we continue to explore the far side of the moon, we can look forward to a future filled with groundbreaking discoveries. The coming decades promise to be an exciting time for lunar exploration, as we delve deeper into the mysteries of our celestial companion and expand our horizons beyond the familiar.